Hello viewers, welcome to today's lesson. This is the Solution Space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want to treat a new topic with you, and that is vectors. As you can see from the board, I've written vectors on the board, okay? And vectors is one of the topics in mathematics which is very broad because it has many areas, and I'm going to take my time and lay a very good foundation to the topic vectors, okay? We are not going to rush it. We are going to take our time and lay a very good foundation to it from the basis, okay, so that you can get a perfect understanding of it, okay? And I will advise that please don't miss out on any of the videos that I'm going to make on the vectors, okay? Because if you miss out on some of the videos, then you are likely not going to understand it, okay? So please do all to follow all the videos that I'm going to make on the vectors so that you can get a perfect understanding of it. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel. Okay, so let's go ahead and look at what I want us to handle in this session. Okay, so which is introduction to vectors. Okay, as you can see from the board, I've written introduction to vectors on the board. Okay, and that is what I want to teach you in this session. Okay, and in the next video we are going to look at addition and subtraction of vectors, okay? But in this session I want us to do a brief introduction to vectors, okay, so that you can appreciate the topic, okay? So we are going to start by defining what vectors are, okay, and also we are going to look at some other things that will aid your understanding when we speak of vectors, okay, so that whilst we build further, you can easily understand it, okay? So now, let's start with the definition of a vector, okay? So now, in simple terms, when we speak of a vector is any quantity which has both magnitude and direction, okay? I'm going to repeat it one more time. So I'm saying that in simple terms, when we speak of a vector is any quantity which has magnitude and direction, okay? So the key words here are magnitude and direction, okay? So we are supposed to know what magnitude is and also what direction is when we speak of vectors, okay? And I'm going to use a practical example to explain it to you, okay? So we are going to look at an example like displacement, okay, because displacement is an example of a vector, okay, because it has both magnitude and direction. And don't forget the definition of a vector. We said that a vector is any quantity which has both magnitude and direction, okay? And we are talking about displacement here because displacement is an example of a vector because it has both magnitude and direction, okay? And I'm going to use that definition of displacement, okay, to explain the direction of a vector to you and also the magnitude of a vector, okay? I hope you understand up to this point, okay? So now let's talk about displacement, okay? Now, in simple terms, when we speak of displacement, okay, it simply means that the change of position, okay, of an object from one point to another point, and that is displacement, okay? As simple as that. I'm going to repeat it one more time. Displacement simply refers to the change of position of an object from one point to another point, okay? So let's say you have an object at point A, okay, and you move that object from that point A to another point, let's say point B, then we can say that there has been a displacement of that object because the object has been moved from its initial point, which is the point A, to another point, which is point B, okay? So that is displacement, okay? Let's go on the board so that I can do a further explanation, okay? So now, let's say I have a point P here. Okay, let's say I have point P here. This point P. Okay, and let's say I have point Q here. So this is my point Q. Okay, let's say I have an object. Okay, at point P. Let's say I have a ball there. Okay, let me say I have a ball at point P, and I move this ball from this point P to the point Q. Okay, you can see that there has been a displacement of the ball. Okay, because the ball was initially at point P. Okay, and now we've moved that ball from that point P to point Q. So there has been a displacement of the ball. Okay, so the change of position of an object from one point to another is what we refer to as displacement. Okay, and in regards to that, there are two things which are involved here. Look on the board, you can see that we've moved the ball from this point P to point Q. You can see that there's a distance that is covered. Okay, I hope you agree with me. So the distance that is covered, okay, moving the ball from this point P to this point Q, that distance that is covered, that is what we refer to as the magnitude of the vector. Okay, so the distance between these 2 points, okay, which is the point P and the point Q, that is what is referred to as the magnitude of the vector. Okay, which in other words, it means that is the length of the vector. So when we speak of the magnitude of the vector, it simply refers to the length of the vector. Okay, so now again, I'm going to go over one more time. So having a ball here at point P, we've moved that ball from the point P to point Q. Okay, you can see that there's a distance covered. Okay, and that distance that's covered, that's the distance between point P and the point Q, is what we refer to as the magnitude of the vector. And the magnitude of the vector simply means that the length of the vector. Okay, so the length between this point P and the point Q is what is known as the magnitude of the vector or the length of the vector. I hope the explanation is clear enough up to this point. Okay, now let's look at the direction of a vector also. Okay, the direction of a vector simply refers to where the vector is pointing. Okay, so let's go on the board again. So you can see that we move the ball from this point P to point Q. Okay, what's the direction of the ball? The ball moved from point P to point Q. Okay, so the direction was towards point Q. Okay, and how do you represent the direction? We use an arrow to show the direction of the vector. Okay, so now moving this ball from point P to point Q, we can see that the direction is from this point to point Q. Okay, so we use an arrow to represent the direction of the vector. I hope you understand up to this point. Okay, so the direction of this vector is that it's moving from point P to point Q. That's the direction of the vector. Okay, so the direction of the vector is pointing towards what? Q. It's moving towards Q. Okay, and we use an arrow to represent the movement or the direction. Please, I hope the explanation is clear up to this point. Okay, so two things are involved when we speak of displacement. Okay, that's the direction and also the distance that was covered. Okay, the distance speaks of the magnitude of the vector, which is the same as the length of the vector. Okay, and the direction simply refers to where the object is pointing towards or where the vector is moving towards, and that is the direction of the vector, and we use an arrow to show that. Okay, that's why I've used an arrow showing that I'm moving from point P to Q. Okay, so if I'm to write this as a vector, okay, I'll write it as PQ. Okay, then I'll bring an arrow on top. Okay, the arrow which points towards Q. So from P, it means we start from P and it goes to what? Q. Okay, that's the direction. Okay, so PQ. I hope the explanation is clear enough up to this point. Okay, so I'm going to use another practical example to explain it to you. Okay, so let's take another example like force. Okay, force is also an example of a vector. Okay, because when we define a force is simply a pull or a push, okay, of an object. Okay, so let me do an illustration on the board, okay, so that it can be easy for you. Okay, so let's say I have point S here and I have point Y here. Okay, I have point S and point Y on the board. So let's say I pull an object, okay, from this point Y to point S. Okay, so there's an object here, whether a ball or whatever you can think of. So I pull it from point Y to point S. Okay, the distance that is covered from this point Y to this point S, the distance between them is what is referred to as the magnitude of the vector or the length of the vector. Okay, and which direction was it pulled in? Okay, it's from Y to S. So in this case, our arrow will point towards S, okay, because the object was pulled towards S. Okay, so we use an arrow to indicate it. Okay, I hope you understand up to this point. So if I'm to write this in vector form, I'll write that my YX, okay, you write your YX, okay, like this. So this is the vector for this illustration. I hope you understand up to this point. Why? Because we are moving from point Y to point X. Okay, so look at it. So we are starting from point Y, okay, and the arrow is pointing towards X. I hope you understand. Okay, so that's how to illustrate vectors. Okay, I hope the explanation is clear enough up to this point. Okay, so I'm going to clean this so that we can proceed further. Okay, so now in geometric terms, okay, we can say that a vector is a directed line segment. Okay, so it means that we can illustrate a vector on the Cartesian plane. Okay, when I say the Cartesian plane, I just mean the y-axis and the s-axis. You know, when you are using a graph, okay, you draw your y-axis, you draw your s-axis, that's the Cartesian plane. Okay, so on the board I have an example there, okay, to do a further explanation. Okay, so this is my y-axis, this is my s-axis, okay, and this is the point of intersection of the y-axis and the s-axis, so that's the origin. Okay, as I've labeled it O, so that's the origin. Okay, and you can see that I have a distance from this origin to the point A, which is here. Okay, so look at the arrow. The arrow is pointing towards A, so it's moving from where? The origin to A. Okay, and anytime a vector moves from the origin or the vector starts from the origin, we call it position vector. Okay, so position vectors simply refers to vectors which start from the origin. Okay, I hope the explanation is clear enough up to this point. I'm going to repeat it one more time. Okay, so I'm saying that position vectors simply refers to a vector which starts from the origin. Okay, so look at this one. We have the vector OA, where O is the origin. Okay, so starting from the origin. Okay, so OA. So moving from O to A, we call it position vector. Okay, so let me write it on the board. So I have OA as a vector on the board. Okay, I hope you can see it. Okay, so I think it's not clear enough. Let me clean it and write it well so that you can see it well. Okay, so I have OA. Okay, I hope this is clear enough now. Okay, so I have the vector OA. Okay, meaning it's a position vector because it starts from the origin. Okay, so having a vector which starts from the origin, we call them position vectors. Okay, and position vectors are represented by small letters. Okay, so this vector OA, it can be represented by a small letter which is A. Okay, so we represent this as A. Okay, position vectors are represented by small letters. I hope you understand up to this point. Okay, now, so I can represent this one by A. Okay, now we have OB. Okay, the vector OB moving from the origin, which is the O, to B. Okay, so that's also a position vector. Okay, because it's a vector which starts from the origin. Okay, from the origin, look at it, from O to B and the arrow is pointing towards B, okay, meaning that it's moving from O and it is ending at where? B, from O to B, okay, so we can have our vector OB, okay, equals to, I told you it's a position vector because it's starting from the origin, and position vectors are represented by small letters, okay, so we can represent this one by a small letter B, okay. I hope you understand and you agree with me up to this point, okay. So that's the explanation of position vectors, okay. I hope you understand up to this point, okay. So now vectors can be represented in two ways, okay. I'm going to show you that, okay, and it's very simple, okay. One, the first way we can represent a vector is one, the column or component form, okay, and two, the magnitude and bearing form, okay. I'm going to repeat it one more time. We can represent vectors in two ways. One, the column or component form, and two, the magnitude and bearing form. And I've not taught you bearings, okay, so we are just going to focus on the component or column form, okay. Then later on when I teach you bearing, we can look at the magnitude and bearing form of representing vectors, okay. So in this video I'm just going to show you the column or component form of representing a vector, okay. So now let's say I have the vector A, okay, let me write it. I have the vector A equals to SY, okay. Now this S and the Y, they are the components of the vector A, okay. So that's the representation of a vector in the component form or in the column form, okay. So this is how you write a vector, okay, in the column or component form. So when this S and the Y, the S here and the Y here refers to the component of the vector, which is the vector A, okay. I hope you understand up to this point. Now the S here simply means a measurement along the S-axis, and the Y here simply means a measurement along the Y-axis, okay. So if I have, let's say A, let me say I have A equals to, I hope you can see, yeah, A equals to, let's say 3, 4, okay. I have the vector A equals to 3, 4. So the 3 and the 4 are the components of the vector A, okay. So that's the component or column form of a vector, okay. Where the 3 here, the one at the top, the 3 here is a measurement along the S-axis, and the 4 here is a measurement along the Y-axis. I hope you agree up to this point, okay. It's very simple. All that I'm saying is that, you know, the number at the top, okay, simply refers to the S part, okay, and also the number at the down refers to the Y part, okay, because the Cartesian plane, we have the Y-axis and we have what? The S-axis, okay. So the top number is just a measurement along the S-axis, okay. So that top number is a measurement along the S-axis, that's the S component, okay. And also the down number is a measurement along the Y-axis, which is the Y component, okay. So that's the explanation. I hope you understand up to this point, okay. So I'm going to clean this one, okay, and let me write one more example. Let me say I have CD, okay, CD, the vector CD, okay. Don't forget about the arrow who is supposed to come, okay. If you don't bring the arrow on top of it, okay, then you are not representing a vector, okay, because the arrow on the top, okay, is very important, okay. That's what defines it as a vector, okay. So meaning that you are moving from where? Point C to D, because the arrow is moving from C to D, it's pointing towards D, moving from C to D, okay. Let's say I have CD equals to -3, let's say -10, okay. So this -3 and this -10 just refers to the component of the vector CD, okay, where -3 is a measurement along the S-axis and -10 is a measurement along the Y-axis, okay. So of course it's negative, so the negative x-axis, and this is also negative 10, so negative y-axis. I hope the explanation is clear enough up to this point. Okay, so I'm going to clean this one. Okay, and let me proceed. Okay, so now this OB, okay, from the origin, okay, to the point B here, it's a position vector. I've already explained it, and I said that we represent position vectors by small letters. Okay, so OB, so I can represent it by B. Okay, so the letter B. Okay, so, and also I have AB. Okay, you can see that the arrow is moving from A to B. Okay, so that's the arrow, meaning that you are moving from A to B. Okay, so we can have A, B as a vector. Okay, so that's the illustration. Okay, so I hope the explanation is clear enough up to this point. Okay, so what we've looked at in this video is that we've been able to define what a vector is, okay, and we've used some examples of vectors, okay, to explain what we mean when we speak of the magnitude of a vector and also the direction of a vector. Okay, and also we've looked at position vectors, okay, which simply means that a vector will start from the origin, and position vectors are represented by small letters. Okay, we've explained that, and also we've looked at representing vectors in the component form, okay, or the column form. Component form or the column form is the same thing. Okay, with the magnitude and bearing form, that one I'll tackle it later when I teach you bearings. Okay, I hope you enjoyed the lesson and you understood the explanation as well. Please don't forget to like the videos and also share the video as well. I'll see you again in another video whilst we look at addition and subtraction of vectors. If you are watching for the first time, please follow the page and also subscribe to my YouTube channel. Bye bye.